Do you remember the Vieira XF-1, which I showed in the last two videos? It's the fastest car in history, but its creator, Miguel Vieira, wanted more. He continued to improve the design of his no-rules F1 car until he reached the state-of-the-art with the Vieira XF-2, the second generation of the Vieira Extreme Formula project. The numbers behind it are wild. 700 kilometers per hour top speed, up to 16 tons of downforce, 0 to 100 kilometers per hour in less than half a second, and 0 to 700 kilometers per hour in 3.5 seconds. This impressive acceleration generates more than 20 Gs or 20 times the force of gravity, so the cockpit had to be completely redesigned with reclined seats, head restraint, and pure oxygen supply, which is filtered from the air around the car, and the driver must undergo extreme training and wear a spaceship-like G-suit. And now you must be wondering, how does this car do all this? Well, the answer is simple. The Vieira XF-2 uses the same combustion engine of its predecessor, which is a 3.5-liter twin-turbo V12. In the XF-1, this engine was fueled by a hydrogen-based fuel with stabilizing and lubricating additives, the Vieira X-Fuel Mark I, and produced 2,870 horsepower. But in the XF-2, the fuel is the Vieira X-Fuel Mark II, which is also made with hydrogen, but its new additives include a metallic compound that increases the energy of the explosion in the engine, giving an extra 50 horsepower, so the internal combustion engine alone produces 2,920 horsepower, but it's not alone. The XF-1 had two electric motors, one on each rear wheel, which, with superconducting graphene wires, produced 900 horsepower each, but everything was improved on the XF-2, so there are four electric motors, one on each wheel, all with the same superconducting graphene wires of the XF-1, but with magnetic inner walls and skeletonized structure made of a composite that we'll talk about later in the video. They're a lot lighter and more powerful, producing 1,157.5 horsepower each, so the Vieira XF-2 have a total power output of 7,750 horsepower. Now, let's talk about the material that's used in this car. It's a composite created by Miguel Vieira, initially for confidential purposes that we're going to uncover soon in this channel. Called hexagraphene, it's a top-secret composite whose main materials are graphene and artificial lonsdaleite, which is a carbon crystal also known as hexagonal diamond. Discovered in 1967 in Canyon Diablo, Arizona, the lonsdaleite is found on meteorite debris, and virtual simulations discovered that it's harder than diamond. That's why Miguel Vieira chose hexagraphene for his car. It's lighter than carbon fiber and more resistant than diamond and titanium together. This makes the car weighing only 342 kilograms with driver and fuel, resulting in a formidable power-to-weight ratio of 23.2 horsepower per kg. The rear is all about downforce, fan car technology, double diffusers, extra long rear wing, and blown diffusers. Fan car technology is basically a fan on the rear of the car that sucks the car to the track, generating, literally, tons of downforce. In the Vieira XF-2, this fan have variable angle blades, acting as a drag reduction system on the straights and working together with the car's advanced floor, which is equipped with adaptive Venturi tunnels for straight line stability. The double diffuser works by expanding the airflow area at the rear of the floor relative to the airflow area under the center of the car. This expansion causes the air under the car to move at a higher velocity, decreasing the pressure under the car and creating downforce. The blown diffuser accelerates the airflow beneath the car by ejecting out air from its underside. This creates a low-pressure area beneath the car, thus generating downforce. The Vieira XF-2 is equipped with advanced active aero with multiple surfaces that can completely change the car's aerodynamic properties in milliseconds thanks to graphene-wired microservo motors, each one smaller and much lighter than a coin, which in turn are controlled by an advanced military-grade AI that is also used for sensor fusion, like in a fifth-generation fighter jet, and, most importantly, for assisting the driver in the control of the car, correcting the driver's mistakes, and even taking full control of the car in an emergency. This last feature not only keeps the car constantly at the perfect racing line, it's an indispensable feature considering the formidable speed that this car can reach. A driver would never have enough reaction time if something happens at more than 700 kilometers per hour. Other features that helps with the car's aerodynamics, and also with the visibility, is the frameless fighter jet style canopy covering the car's closed cockpit, and also the covered wheels, because exposed cockpit and wheels cause drag. The car's impressive maneuverability comes from its supreme downforce and three more factors: four-wheel steering, torque vectoring, and its insane suspension system. A magnetic active suspension that is linked to the car's central AI and to a network of LiDAR sensors in the car, which basically use lasers to scan the car's surroundings, adjusting the suspension stiffness and ride height in real time, thus canceling the vibrations created by any type of curb or irregularity in the track. The Vieira XF-2 also features a biomimetic treatment over the bodywork with microscopic scales inspired by the Mako shark's skin. This scales, together with covered wheels, closed cockpit, and active aero, reduce drag to insignificant amounts, giving the car a drag coefficient of less than 0.18 compared to the 0.9 to 1.2 of current F1 cars. As you can imagine, no current tires in the world would ever withstand the extreme forces that this car can generate, so Miguel Vieira had to develop new tires specifically for this car. These tires are the Vieira X Tires Mark II, made from a top-secret rubber composite with silica, and a special type of material called phase change material, or PCM, a material that melts when heated above the temperature it is designed to maintain, absorbing heat in this process and releasing the heat back when it cools and solidifies. The X tires are also reinforced with a lightweight graphene mesh for puncture resistance. These tires can race for up to 500 kilometers with a degradation of less than 5%, easily finishing a 300 kilometers F1 race on a single set of tires, thanks to the PCM and another feature of this tires, microcapsules with a self-healing polymer that can automatically repair the tires when they start to wear out. But what about performance in wet tracks? Well, these tires can automatically create microchannels on their surfaces to drain away water. When activated, these microchannels become hydrophilic, and the rest of the tire become hydrophobic, so the water is naturally forced to go into the microchannels. In the dry track, the grip coefficient of the Vieira X Tires Mark II is 4 and 3.5 in the wet track, while the current F1 tires have a grip coefficient of only 1.8 and basically zero grip in the wet track, in which F1 cars have to use intermediate or wet tires with a much lower grip. Introducing the Vieira XF-2, the world's fastest car ever, designed by Miguel Vieira.